Bet you didn't know I was a natural blonde. Just kidding. We interrupt our regularly scheduled programming to bring you an important news announcement about nuclear chemistry. Ever wondered about the history of nuclear chemistry? Probably not, but we're gonna tell you anyway. Scientists that impacted this area of science include Henri Becquerel, who discovered radioactivity in 1896, Wilhelm Röntgen, who discovered X-rays, Marie Curie, who discovered radium and polonium, Ernest Rutherford, who realized radioactive decay could be described by a simple equation, Frederick Soddy, who proposed radioactivity is the result of a natural change of an isotope into a different element, and Otto Hahn and Fritz Strassmann, who demonstrated nuclear fission. Speaking of nuclear fission, unstable nuclei can stretch so far that the strong nuclear force is no longer strong enough to hold the nucleus together, and the electric force breaks through the process of fission. On the other hand, stable nuclei do not change from one element to another because the strong nuclear force holding the nucleus together is greater than the electric force pushing protons away. So now you're probably wondering how this could relate to your life. Well, has this ever happened to you? Hey, Alyssa!
Oh, Martha! Help! I'm falling! I can't get up! Only had life alert!
Well, I don't know about life alert, but it looks as if your arm is broken. Well, thanks to the works of this guy, you can go get an x-ray.
Alright! Wait, you carry that in your pocket? Is that just something you carry around with yourself?
Yeah.
Okay, well, wait, what's an x-ray?
X-rays are a form of electromagnetic radiation emitting high-speed electrons. The electrons go through all tissues and organs to be absorbed by the bones. This allows doctors to take a picture of what the bone looks like before the radiation exits the body.
That sounds painful.
Well, X-rays are pain-free and increase the ability to detect disease or injury early enough to be treated.
Well, are they expensive?
Actually, they are notably less expensive than MRIs and are the fastest method of finding what's wrong with you.
So what's the catch?
Well, side effects may include, there's a small possibility that the chance of getting cancer will increase slightly, but as long as the proper precautions are taken, there's nothing to worry about.
I don't know. Cancer sounds pretty serious.
Well, like I said, as long as you wear a lead vest, it's all good, girl. Besides, wouldn't you rather have your arm properly examined rather than the risk of not letting it heal properly?
Well, when you put it that way, I suppose the benefits outweigh the risks.
You know, we should probably go to the hospital now.
Good idea.
Remember everyone, x-rays are always a good idea in the event of an injury, so stop by your local ER and get an x-ray today!
To wrap up our presentation, let me mention a few more details about nuclear chemistry. The main different kinds of radiation include alpha, beta, and gamma. Alpha particles are helium-4 nuclei, which means they have 2 protons and 2 neutrons. They only penetrate a few millimeters of thin material, such as paper, so they do not penetrate skin or tissue. Beta particles consist of an energetic electron. It is stronger than alpha radiation, but not as strong as gamma. Beta radiation can be stopped with a sheet of plastic or metal. It occurs when a neutron decays into a proton in the nucleus. Gamma radiation penetrates much further through matter than either alpha or beta radiation. Lastly, let's talk about nuclear fission versus fusion. Nuclear fission is the process of splitting a large atom into 2 or more smaller ones. This process does not normally occur in nature, but produces many highly radioactive particles. It takes little energy for fission to occur, but the energy released during fission is 1,000,000 times greater than that released in a chemical reaction. Nuclear fusion, on the other hand, is the fusing of 2 or more lighter atoms into a larger one. Fusion does occur in nature in stars like the Sun, unlike fission. Fusion requires extremely high energy, but the energy released is 3 times greater than the energy released by fission. To leave a comment about our video, please call 1-800-WE-DESERVE-AN-A. That's 1-800-WE-DESERVE-AN-A. Thank you for watching, and good night.